Hi guys, I hope everyone is doing well. So today I am going to share with you how to generate millions of NFTs using Python and not using any PySpark or any big data. I am using Dash, Pillow, Base 64 and BytesIO alone. So for the first step, I am taking the existing functionality that generates a single NFT image by batching any of the YouTube video. You can prepare this YouTube video. In this, we have given the code to generate NFT art for a single image. So I am going to run the functions now. First, I am going to run import. Then this function, which I am not going to go into detail because this is already covered by another YouTuber. The only extra function is pill image, converting pill image to base 64 encoding. So instead of saving the image in the existing functionality, I am encoding the image according to the pill image. So what is happening is I am figuring out how to store images efficiently. The answer is simply create a function that stores the image in a format of base 64 encoding or simply hashing it in terms of a string of bytes. Step 3 is creating functions for everything and then create one more function for pagination loop implemented with the help of dash. So for that also I have given the link. I will run it. Okay, and then I will show you the output, and I am scaling it up to a millions of images. I will run the app. So here you can see 5 images in one page. If I increase the page count to 2, I will get 10 images, and these are not randomly generated images. The images are getting stored in the data structure. Suppose I click page count equals to 10, then I will get till I will get till 50 images. So total up to million images and five taking 5 images at a time. So million divided by 5 equals to 2 lakh. So up to 2 lakh I can see like this. And you can see previous images are not changing as well. So that means they are getting shaped in a data structure using the concept of pagination loop. So what is happening? I will go through the logic. As mentioned in step 3, in step 3.2 is going to be our main function that takes number of iterations as an input, which can be up to a million. This function generates NFT images on the basis of page size variable, which can be manipulated to your liking. Page size variable is nothing but you are seeing 5 images at a time. If you want to see 100 images at a time, then you can set a page size variable to 100. Now the question arises how to scale these images up to million images at a time. To tackle this issue, what we will do is store all of the images generated for the time into a case dictionary and make it a global variable. So when we go back to see these images again, the images will not be generated again. Instead, it will be taken from cache dictionary directly. Also, we need to set a cache dictionary as a global variable before declaring it so that its scope becomes global and we do not run into non-existence of a variable error. The final piece of this puzzle is to collect the generated images from cache dictionary, store them into a temporary array of predefined page size, and then styling them up a bit. So you can see there is some margin here and there is some border also here for the images. So that is the styling part. After the array of images is generated, we can show them to any front end. Here we are using dash for this purpose because it comes into custom pagination loop property as well. So I will show one more time. If I change the page size to 10, Then 10 images will be generated in a single page. So you can see 10 images are getting generated. Suppose if I do the page count equals to 20, you can see till 20 images are being generated. 30, 40, 50, till 200 images you can see. And these all are occurring in the cache also. So these are not random images. So by changing the page size variable, you can see different kind of NFT generated. And as a final piece of homework for you and an advice for you, take this code from my GitHub link and optionally we can choose to save the image also. Try to implement it functionality also as your homework. Alright guys, this is for this photo. Thanks for having me.